Hi, everyone. This is Dr. Cheryl Selman, and welcome to What Women Must Know. Thank you for joining me. This is always a great opportunity to have profound and in-depth conversations about many topics that are really relevant to our health and well-being. And I'm so happy that you're joining me for another episode on Progressive Radio Network. I also want to invite you to go over to my Facebook page, which is What Women Must Know, and you can like me over there, or go to my website, which is drcherylselman.com, and opt in there, because either way, you will get the archive shows that I do every week. In fact, I have a second show on Progressive Radio Network called The Love Code, and that's more of a spiritual show, so that show really is designed to uplift and transform and tap us into our spirit. This show is all about empowering you with truthful information so you can make the most educated and aware decisions possible for your life and well-being. And again, thanks for joining me, and stay tuned for a really great conversation. Actually, a very fascinating conversation. So we're going to be talking today about the new green technology for roads and a whole lot more. And my guest is Bob Sherwin, who is the founder and CEO of Lithified Technologies, and the manager partner of Lithified Technology Group, LLC, which owns the IP for all the LithTec products worldwide. Bob received his Bachelor of Science degree in 1979 from the University of Oregon, and Lithified Technologies US LLC is based in Santa Fe, New Mexico. So if you're wondering what this is all about, stay tuned, because this is going to be a fascinating conversation. So first of all, let me just welcome Bob Sherwin to the show today. Hello and welcome, Bob.
Thank you, Cheryl. Nice to be with you today. Thank you.
And it's great having you. And I just want to share with everyone that we actually have met. In fact, I've just spent a little time with you and your beautiful wife and good friend in New Mexico, because we connected when I was in Costa Rica in February. So we were at a retreat center that I've talked about before called Rhythmia, and you were a guest there, and I was a guest there, and we just connected and created a bond. And as a result, not only did I create two new wonderful and special friends in my life, but you really opened me to this technology that you are passionate about, that you are doing great things with all over the world that I knew nothing about. And I just wanted to have you on the show because we have had guests in the past who've talked about regenerative agriculture, which is becoming so important, and people are learning more and more about how to regenerate the environment. And this is a facet of understanding how to regenerate the environment, but with a technology that is revolutionary. And we're going to start with its application to our infrastructure and roads, but it does a whole lot more than that. So, having said all of that, Bob, I'm just going to have you jump in and begin this conversation and explaining. Let's explain what the infrastructure situation is in our country. We'll start in our country because it's probably true in many countries. But when we talk about the state of our roads, what is really happening there?
Well, there are 1 million miles, a total of 4 million miles in the United States of roadways, and 1 million of those roads, a quarter, are at this point deemed as failing roads through the Association of Engineers in the United States. They have been graded at a D or less, and so the cost to construct roads is exorbitant, and the largest line item budget for cities, counties, and state DOTs, and they have about a $200 billion budget each year, which sounds like a lot of money, and it is. But when you look at the cost of building a lane mile, just 1 mile of one lane can be anywhere from $750,000 to $1.5 million, depending on how thick the asphalt is and what kind of conditions that they're having to deal with. And so to rehabilitate the 1 million miles of failing roads, they're looking at $1 trillion to be able to do that. And in road construction, there's a saying that roads wear from the top, but they fail from the bottom. And the technology that we have developed is a green technology that's designed to build the foundation underneath the road and provide anywhere from 60 times the strength of the existing base course, which is a sand and gravel mixture that goes underneath the asphalt. When we treat that, we can increase the load-bearing capacity, the strength of the road there's a measurement called resilient modulus that the average strength of a base course is 25,000 PSI modulus, and we can take that over 2 million PSI modulus. We typically will shoot for a minimum of 500,000 because that's the same strength as asphalt. And
wait, before we get into all these technical things, because I'm sure it's like pushing people into some new worlds and new dimensions. I have a couple of questions.
Sure.
What happens when our roads fail? I mean, I don't mean the process of degradation, but I mean what happens to a society when roads fail? What is the risk to our society from this failure of our infrastructure?
Yeah, I think the biggest challenge is safety hazards, number one, when there are potholes and crumbling infrastructure and people blow a tire or lose control. There's the immediate safety factors, but it continues all the way down to the value of your home. For example, when you're in areas where you're so remote and the infrastructure is so poor, then that all ends up taking the toll all the way down to the desirability of where somebody wants to live or what they want to put up with that can completely impact the value of their homes, the difficulty of commuting and getting to a job. There's all kinds of factors that come into play with that.
I don't think people really give that much thought. It's not just the risk to your health, to the maintenance of your vehicles, which is the obvious thing. But the economic part of it is really interesting. That the value of homes and even communities can go down because it's dangerous or poorly accessed. There's so many consequences. I guess unforeseen consequences when you don't have a properly functioning road system.
On the Navajo Nation, where we work with the Navajo Nation, which is located in New Mexico, Utah, and Arizona, and you can take this example to the extreme where they are so remote and they don't have access to even base course, sand and gravel to put on top of the native soil. So when it rains in the monsoon seasons or snow, that mud is a clay that is so slippery that now you have the inability of people even getting to a hospital if they had an emergency or access to get to school. It is really sad to see some of the conditions that they live on, and this is happening here in the United States. And so there's a whole spectrum of ways that infrastructure and roads can impact us, depending on how fortunate we are to have a high-quality infrastructure around us or not.
You know, as you're talking, I remember being on some of those roads in Costa Rica, and Costa Rican roads, it takes forever to get from one place to another because the roads in general are so bad, filled with potholes. And, you know, I remember traveling on one of those roads for, you know, a couple of hours, and, it was a snail's pace, and you had to navigate around these gaping holes, and there's kids on bicycle and adults on bicycles coming around, and, you know, it's like people coming in both directions. I mean, it was so hard on your focus and concentration, your energy, because you had to be present, and God knows what it's doing to all those cars and trucks over there, because those potholes are really deep, and they're just, like, persistent, you know. So, you know, I get what you're saying. It could be a disaster for a culture to have such dilapidated roads, especially in the movement of goods and whatever else as you were saying. The other question I have is, why is it that roads fail from beneath? You know, where from the top but fail from beneath. I never knew about that. I don't know anything about road construction. At least I didn't know much until I had conversations with you, but I'm sure most people don't have a clue. So what is it that goes on? Why aren't roads wearing better?
Yeah, it's a good question. First of all, when you look at the layers of what's going on underneath a road, the native soil, sometimes called the in situ soil, that's whatever Mother Nature left there, and it could be anything from blow sand up to a very expansive clay. And so there's sand, silt, clay, loamy soils. There's all kinds of different kinds of soils. And so the first thing that they have to do in constructing a road is stabilize the in situ soil to build a platform, if you will, to be able to build a road on top of it. If you build a road up on top of clay can expand and shrink at great volumes that it can actually throw the whole road. We've all walked down a sidewalk before where there's a whole section of concrete that's lifted up and 6 inches off of where it should have been, and that's clay expanding underneath that sidewalk. When you're in sandy soils that are shifting and moving around, there's nothing to hold it together. These are some of the challenges that they have to figure out how to stabilize that foundation, and then they bring in a layer that's called the subbase. And the subbase is typically a sand and gravel mixture that's larger, like 1.5 inches minus in size, and then they build it up to the next layer, which is the subbase, and then so you have the subbase and then the base, and on the base layer, that's generally 3/4 inch minus rock and sand, so it's getting tighter, more dense, more compaction, and then they put the asphalt or concrete or there's a surface called chip seal that's a much thinner layer. But those are the different kinds of surfaces that you can put on a road. And so what causes them to fail, there's 3 primary reasons. The top 2 are water, and the second one is weight loads. And so what happens is water will always find its way into the base layers. The asphalt will crack. It's caused from contracting and expansion with, cold and freezing temperatures that in the heat in the summertime that move the asphalt around until it cracks, and it can also infiltrate from the sides. And so water gets in and will erode away the base course underneath it and create a cavity underneath the asphalt, so that eventually a truck comes along and breaks off that asphalt because there's nothing underneath it to support it, and that's your first pothole. And if there's any gravity to the road, then water gets in and starts following the gravity and running down, and then you get all the long cracking. And so the second way is weight loads. And we have an interesting thing happening in the last 10, 15 years in the United States, and that is we've seen all the big box stores, the Walmarts, the Costcos, and all of them have tremendous amount of inventory and products that are shipped to these locations. And then you have Amazon and shipping online. All of the amount of shipping that's taking place in the United States is at an all-time high. There are 15 million 40-ton trucks on the highway today, and the 40-ton truck is the maximum weight load that you can put on the road without a special permit. So it's all the 18-wheelers that you see going down the road. And the thing that's astonishing to me is that there's a study that says every one of those 18-wheelers going down the road have as much wear and tear on the asphalt highway as 10,000 automobiles.
Wow.
Think about it.
One
has the same wear and tear on the road as 10,000 automobiles. So you can see the impact of weight has on a road. And we've never had more weight loads and more 40-ton trucks trying to support the nation's shipping. And so that's where the foundation of the road is going to determine how long it lasts. It all comes down to supporting the weight load and keeping the water out. The third component is in the freezing temperatures. When water gets into the foundation, it's called frost heave or freeze-thaw conditions that will actually, water in the foundation expands up to 11%, creating long ice crystals that raise up the foundation underneath it, lifting the road up in the air, and it can create these ups and downs in the road that are like a roller coaster ride for a vehicle.
And really, the technology of road building doesn't sound like it's changed very much in a really long time.
I'll tell you how long it hasn't changed. There's you can go online and look at the ancient Roman road system, and it's incredible. I don't remember the exact number of miles. It's astonishing. Something like 50,000 miles that the ancient Romans built of roads. Crazy amount of roads. And they put, big rocks on the bottom and little rocks on top, and instead of asphalt, they put pavers, like stone pavers. And some of those roads are, 2,000 years old. They're still in place today. But today's technology is really big rocks on the bottom, little rocks on top, and the only advancement has been the asphalt or the concrete that goes on the surface instead of the road paver. So technology and, the base course model has been around for at least 100 years, and it's, worldwide. The same technologies are used everywhere in the world.
So tell us about the technology that you have been developing and researching. I know you've put, at least 15 years into this, just the research to get this to be viable. What is this that you are involved with that is considered a green technology for roads?
Well, we've been through a lot of iterations over the years, and it's really interesting. If you go back to the 1980s, is when soil stabilization alternatives were coming into existence, and it's because of the cost of making base course. And when you look at our traditional methods, and you look at the carbon footprint of what is involved in that, it starts with digging a big pit in the earth. and then they pull out the boulders and they crush them, and they crush them into 1.5 inch minus piles and 3/4 inch piles, and then they mix it with sand, and then they eventually haul it to a storage place, and then when it is time to build a road, to build a standard county road is 24 feet wide and 6 inches of base course. That takes 98 truckloads of gravel to do 1 mile. And so back in the 80s, when the cost of hauling and the fuel costs kept going up and up and up, they started looking for ways to, how can we take the existing soil and give it enough mechanical strength to reduce the amount of import of base course. And there have been a lot of different attempts at it. That would be sulfuric acid was used. Actually, one of the first things that was used was the farmers that would, back in the 40s and 50s and 60s, they would change their oil on all of their tractors and different things like that, and they would save all the oil, and eventually they just spread it on their dirt roads to try to keep the dust down, and it would help stabilize the soil. But finally the EPA says you can't do that. This is getting into the water tables and it's killing the plant life, and so they outlawed that. And then going back into the 20s, they had a technology of when they first started making paper in the paper mills. They had a byproduct called lignin, and lignin comes out of trees, and it was left over, and same thing, they didn't know what to do with it, and they were dumping it into the rivers and killing all the fish and wildlife and plant life, and they said you can't do that anymore. And so they were like, well, what do we do with this? And so they would add water to it and just spray it on their roads to try to keep the dust down. And in some cases, the road would get really hard. In other cases, it didn't do anything. And they learned that in the places it was getting hard, it had a certain kind of clay in that road that had what they call a cation exchange capacity that enabled a chemical reaction to take place with the lignin to get it hard, but it was water soluble, so when it would rain, it would get muddy. And they tried magnesium chloride, which is salt, and salt just is hydrophilic. It pulls moisture out of the humidity in the air and holds it into the road where they've sprayed the magnesium chloride onto the road. I'm talking about a dirt road. And it pulls the moisture out of the air, and it's kind of like you've watered the road, and it keeps the dust down. But the downside is it's hydrophilic. And so when it rains, it attracts water, and everything turns to mud, and so it washes out very fast. And there are enzymes and polymers that are like dirt glue that are trying to glue it together, and tree sap and molasses and even recycled chopped up tires. There's been all these kind of things that have tried to go into the roads, and not one of them have ever received a DOT approval. They've never made it a year under, the seasonal changes and so forth, according to the product evaluation programs in the DOT. So what our product is, we've been through a lot of our own gyrations trying to figure this out, and the biggest challenge is that all soil is made up of sand, silt, and clay and rock, and then you have acidic soil, and then you have high pH soil and everything in between. And they all come together in countless combinations. And, for example, there's 2,000 kinds of clay. So when you have all these kinds of combinations, you might figure it out on one particular soil type, but then the next one it doesn't work at all. And that's what took us so long to figure out. And we went from a liquid into a dry powder and all kinds of things. But we finally have figured out, and we took our lessons came from Mother Nature. And in Mother Nature, there's a process called lithification, and it really means, there's a technical definition, but it really means turning soil into stone over tens of thousands of years. And it happens through naturally occurring minerals that are in the soil, a particular assembly of these minerals that come together with heat, pressure, and time, and sand will turn into sandstone. Clay will turn into slate, and other kinds of soil will turn into stone. When these naturally occurring minerals all come together, well, we figured out what those were, and we figured out some accelerators that would make it happen in 24 to 48 hours instead of 10,000 years.
Which is pretty remarkable technology when you think about that such an acceleration of a natural process. And the result of finding a technology that can replicate the natural lithification process accomplishes what? So what is it that you have been able to create that is so revolutionary?
What we have been able to do is the first two biggest steps were we have the ability to create unprecedented load-bearing capacity. So, again, I mentioned the two factors that really destroy roads were water and weight loads. Those are the two areas that we're literally setting records in. So, as I, tried to say earlier, a typical gravel road would have 25,000 psi modulus. We customize the formula for whatever soil conditions are happening right there. That's the other thing that nobody else has done, is created a customizable formulation that's engineered to optimize the results out of that particular soil and accomplish two things: unprecedented load-bearing capacity, and it's called bound and non-dispersive, meaning you can take a sample of this and put it underwater indefinitely and it will not come apart. So we keep the water out, and we can handle the weight loads, and we can customize it for any kind of soil condition that we come across.
So you've been working on this for 15 years to figure out the many variables and the different climates that you're needing to put this into the road as the base into the road system. And what are people finding as you're using this, as different cities are starting to get interested in what you're doing? What are they discovering? Why are they interested? What's happening out there in the world of infrastructure?
Yeah, just one correction. We actually started in 2011, so we're 9 years into it at this point. But what people are realizing, and a lot of this is trying to figure out where is our niche in the market and what is the best way to introduce what we offer here. But for example, counties have become a big part of our market. And counties oftentimes will have hundreds of miles, sometimes over 1,000 miles of gravel roads that they're responsible for maintaining. And they can't afford $1 million to $2 million a mile for asphalt. And so they just put base course on the roads, and this is your typical gravel road. Well, the problem with a gravel road is that it only lasts for 5 years, 4 to 6 years, depending on the amount of traffic. And what happens is the aggregate gets pulverized. You've got stone against stone underneath the weight of a car, crushing it and turning it into powder. And as the suspensions are bouncing up and down, going down the roads will washboard and become very, very bumpy. And so they have to come in and grade the roads to take out the washboards, and then they have to water it with a water truck and then a flat wheel roller to compact it. And that will only last for about 5 weeks, and the washboards are right back. And so that process is a never-ending throw money at your road and never-ending maintenance issues for the counties. And you can take a typical gravel road, and the cost of gravel is completely dependent upon how far are you from that gravel source. So going back to a county standard of 6 inches of gravel and 24 feet wide and 98 truckloads of gravel, if you're close to it, you could do that for $75,000 to $100,000 per mile. The Navajos are more than 100 miles from the gravel source, so that same gravel road cost them $400,000 a mile. Wow. So what we've been able to show the counties is that when you look at the cost of maintaining that gravel road for 20 years, you're replacing the gravel every 5 years at an average of $100,000 a mile, and then to grade out the washboards, it's $3,000 a mile to take out a grader, a water truck, and a roller, and you do that quarterly, is $12,000 a year in maintenance, and at the end of 20 years, that's $740,000. Well, what we've been able to show them is instead of having just two choices, gravel or asphalt that you can't afford, why don't we take your existing gravel roads, don't bring in any more material. We'll take whatever you've got there and make it rock hard, water resistant, and then put a chip seal surface on it, which is just a 1-inch layer of an emulsion and, little rock chips that are, 1/2 inch to 5/8 inch rock. And they do that in 2 layers. So the black emulsion goes down, then they spread the little rock chips, and then another layer of black emulsion, then the rock chips, and they can even leave it looking natural like we've done with the Forest Service. So it looks like a gravel road, but it's completely bound, and it's more like an asphalt road that just looks like the color of the dirt, color of the rock. But when you put the final black emulsion on it, it looks just like an asphalt road. But in the past, chip seal didn't last very long because you're putting it on top of base course that is shifting and moving, and that's a recipe for a road that's going to fail soon. With us, every inch of road that we treat has the same strength as an inch of asphalt. So if we treat a 6 or 8 inch layer of base, it's like putting chip seal on top of 6 or 8 inches of asphalt. Now that road's going to last a very, very long time. And it's a true hybrid between a gravel road and a asphalt road, and we can do that for $250,000 to $350,000 a mile. So it's cheaper at the end of 20 years. We're at $350,000 a mile with maintenance. So we're 40 cents on the dollar compared to gravel in 20 years, and then of course compared to an asphalt road, we're 25 cents on the dollar. So it's a very affordable technology, and then it's green in many, many ways that we really haven't talked about yet, but those are part of the other benefits to this technology.
So that's quite remarkable. So you are really the first company to revolutionize how roads can be made and repaired and to be sustained for the long term at an affordable cost, at serious reduction of cost to cities and counties and states. And I guess you're starting to roll this out now. So you've got the Department of Transport, DOTs, in several states that are now convinced that this is a proven technology, and they are, agreeing to have roads made with your technology.
Yeah, so it's a different advantage for the DOTs. I gave an example for a county going from a gravel road to a chip seal road, but the advantage for a interstate or a major highway is that typically in a road design they have what they call a structural number or a structural coefficient, and basically what it means is the foundation of the road, when you use base course, has a certain cap. You can only assign so much strength into that foundation, which means that 90% of the strength is coming from the surface, the asphalt thickness. So typically an asphalt road is going to be a minimum of 4 to 6 inches, and sometimes it's 8 and 10 inches thick of asphalt. And so what LithTec offers to a larger, more main highway or interstate is that we are moving the structural credits into the foundation of the road for a fraction of the price, and thereby reducing the asphalt thickness from 6 inches down to 2 inches. And you just save 2/3 of the cost of the asphalt, and the asphalt is already 2/3 of the overall cost of the whole project. So it's a tremendous reduction in cost to have a road that's going to last longer. And so when you have a failing asphalt road, there are currently 3 choices. How do you fix that road? Well, one method is called mill and overlay, or sometimes they call it mill and fill. But let's say there's an asphalt road. I think you've all driven down a road before where it looks like they milled off the top couple inches of the road, and it's real rough. It's still asphalt, but it's still rough where they ground it off. And then they'll come back and they'll lay a new 2-inch layer of new asphalt right over the top of it, and it looks like a brand new road. And so that process is a Band-Aid to making it look good for a year or 2. But the problem that caused the road to fail the first time is that whatever's going on underneath that road hasn't been fixed. And those same problems will resurface in the same areas because roads wear from the top, they fail from the bottom. So to solve a longer-term approach, you have to get into the foundation of the road to see what's going on that's causing it to fail to begin with. And so they have a process that's just been developed in the last 5 to 8 years called full depth reclamation. And what they do is they have a big machine that has like 600 carbide teeth underneath it, and it grinds up all the asphalt on the surface, and it'll take it up a conveyor belt and drop it into a dump truck, and they'll take that to a recycle plant. There are still places that take it to a landfill, but hopefully more and more places are at least recycling the asphalt. And when they recycle that asphalt, they don't put it in the top surface. It goes into the lower layers because the new asphalt is just such a better, higher quality that they want that right on the surface. But in any case, it's hauling all of this recycled asphalt to a recycle plant at great expense, and then trying to re-emulsify it and use it back into the base layers. Well, what we do is, and the third choice is total reconstruction, where they just take off all the asphalt to a landfill or recycle plant, go in and put in all new base course, and then put in a whole new layer of asphalt over the top of it. And when you get into total reconstruction, it's more like $2 million a mile. So what LithTec does is, first of all, we recycle the asphalt right in place. Whoever built that road to begin with paid a lot of money for that asphalt to bring it in, and to have to pay a lot of money to haul it away to a landfill or to a recycle plant is unnecessary with our technology. We'll grind it right up and move and mix it right into the top 6-8 inches of the base course. And our formulation is designed specifically to work with the oils and the emulsion and the gravel to be able to encapsulate it and keep it from remobilizing into the water tables. We passed a EPA test called the EPA SPLP 1312. It basically is a test for leaching to show that we do not leach, and we can take harmful ingredients and keep them from leaching and encapsulate them in what we refer to as nature's concrete. And now the foundation is far stronger than it ever started out to be, and it's water resistant. And now you come in with a reduced pavement design, and you just fix the whole road for a fraction of the price, and it's going to last a lot more.
Well, I am sure this is an education that most people never thought they were going to have on the show. to learn about the whole process of creating roads. I find it really fascinating, and particularly fascinating that you have created a solution to a huge problem that will extend the life of our roads, will be a fraction of the cost. So many cities and counties and states just are struggling to find the revenues. So it has huge implications, and I'm excited. I have to say, it gets me excited to think about this solution. It's like you have the first solution that's ever really been proven and tested. So I just want to move the conversation along, because there's another way to utilize your technology, and that has to do with uranium, the old uranium mines that you told me about that was totally, off of my radar screen. I hadn't a clue what was going on, and I found it so upsetting. And you have a solution to this really serious problem. So can we talk about that a little bit?
You bet. It came to my attention through working with the Navajo Nation and the former president, Russell Begay, who was the president of the Navajo Nation until January of this year. And I learned in working with these people and spending a lot of time out on the reservation that they have 523 abandoned uranium mines that go back to the 60s, 70s, and 80s when the U.S. government went in under an agreement to, have them share in the profits of the minerals and different things, the coal and gold and silver that could be found on their land. And unfortunately, at the end of this process, it left the Navajo land with 523 abandoned mines that people living near them had 10 times the birth defect rates, 10 times the cancer rates. It affected their entire water tables. You cannot, they drilled over 200 wells on the Navajo Nation, and all of the water is contaminated with uranium. Consequently, they have to bring water in from over 100 miles away. And these people, most of which are living off-grid with no electricity, no water, rely on a water truck to fill up some 55-gallon drums of water, to try to make it through the month. And it's really sad. And so we really wanted to see what we could do to help them and try to help solve a problem. And so it started there, and we're fortunate to live in Santa Fe, New Mexico, and not far from here is the Los Alamos National Laboratories, which is the premier laboratory in the United States, and they have been involved in studying the uranium containment since the Manhattan Project back in the 40s. And a year ago, we had entered into a program to have them do testing on our road technology. And they did a one-year study and wrote a 38-page white paper that basically said this is the ideal material under any road. And so we reapplied for a grant because there's only 2 laboratories in the United States that can test for uranium containment. And Los Alamos National Laboratories is far in, as first, as the number one laboratory to do that testing. And through a small business association grant involved with New Mexico, we were awarded a one-year study for the uranium containment. And so in working with the scientists up there, they helped us design what is now called the LithTec U-capping system for capping uranium. And there are certain, well, first of all, I should tell you that the current design from the Nuclear Regulatory Commission for all abandoned uranium mines, and it's not just isolated to the Navajo Nation. This is the thing that I learned as the more we got into this. I could not believe what I found out. The western half of the United States has 15,000 abandoned uranium mines. That is
all leaching uranium into the water
yes,
system, potentially. 50
million people live within 10 miles of an abandoned uranium mine in the western United States, and it affects 50% of the water in the western United States.
Wow.
So this is a massive problem. And so our technology is well, I should first of all tell you what the standard is, what the existing technology is. It up until a year ago or 2 years ago, it used to be just 5 feet of clay that they would put over the top of an abandoned uranium site, and they would compact it and then put a layer of concrete over the top of that. And what happens every time you have clay is water gets to it and it swells. It breaks the concrete, and then water gets in the cracks and erodes away the clay and exposes the uranium. So that was failing all over the place. And so in the last couple of years, they didn't know how to stop the clay from shrinking and swelling and eroding. And so their current design is a foot of clay, a foot of sand, a foot of clay, a foot of sand, 5 or 6 feet deep. And then they don't even bother to put concrete over the top of it. They just put some crushed rock over the top of it and kind of brush their hands together and say, well, we've built it to spec, and they leave. They don't even test it for uranium containment because they know that it didn't work well. It's not a good design, and it will shrink, and it will swell, and it will erode, and it will expose the uranium. So, and the uranium is primarily a dust that they're trying to keep contained because the dust can go for hundreds of miles airborne, and it can last 10,000 years. It doesn't break down. So our design is designed with a particular type of clay that goes into the base layer that acts like a magnet to uranium. Uranium just is attracted to this particular type of clay. And then we lithify it, turning it into like concrete so it does not shrink and it does not swell and it cannot erode. And then we build a layer of 5 feet over the top of that with in situ soil or base course material that we turn into virtually concrete. And when we're done, it acts as a magnet to the uranium, and it will not shrink, it will not swell, and it does not erode. And it's going to be a long-term permanent fix. And so by December of this year, we will have the white paper completed by Los Alamos National Laboratories confirming the extent of uranium containment and compared to the current design, and it won't be close to the current design. So we're excited about being able to offer that kind of a green technology to really help the planet. I mean, everything that we can do are at the core for us. You know, it's about how can we do things in cooperation with nature and help the planet and not be creating so much harm with old traditional methods of digging big pits in the earth and crushing the rock and all the fuel. And in a typical road, 1 mile takes 180 truckloads, compared to using our technology takes 6 truckloads. And you can look at the difference in the carbon footprint, not to mention what it took to make the base course and to produce the asphalt and all those things that are, in their own way, tremendous carbon footprint.
This, to me, is so exciting that, and this is what this time is about. It's really looking at these new technologies that are revolutionizing so many of the systems and the needs that we have right now, and evolving the process. The story about these 15,000 uranium mines that are poorly, hardly capped at all, and leaching into the water, and all these people who are suffering with cancer and birth defects. I had no idea. That's an environmental disaster which you never hear about, right? You never hear about that. Well, I never heard about it anyway, so I don't think most people would even know that there are 15,000 uranium mines in the western states affecting 50 million people. You know, that is incredible.
Yeah.
But you know, what's so exciting is that the technology that you have put your heart and soul into and a lot of investment is turning out to be so profound in improving the quality of our lives in so many ways. And I just, in the few minutes we have left, I want you to talk about the way that it's being used to create bricks for building homes. That to me is really fascinating. Can we just share a little bit about that?
Yeah. Basically, you know, turning soil into stone can be used in so many different ways. A lot of people don't realize it, but the second most used thing on the planet by humans next to water is concrete. 6 tons of concrete is for every human on the planet is produced every year. So it's a tremendous thing. And so with taking earth and putting it in a hydraulic press with a mold that can put in any shape of block that you want, we can make adobe blocks. We can make interlocking blocks that are like Legos, basically, that just stack and they're interlocking on all sides. So in a hurricane, the whole wall could wave, but you can't get a block out. You know, because they're all interlocking and without mortar. So it's a great technology to be in the hurricane environment. Another technology, I'll just speak to some of the green things real quickly, is biofuel is one of the exciting things right now. And biofuel, for people who don't understand this or know this, it comes from growing algae, and they have been able to design the algae to work with the algae to produce. Back in the day, it was just biodiesel, but now they have biojet fuel, biocar fuel, biofuel for your home, and it's all through these type of algae that grow in ponds that are very shallow. They're only 10 to 12 inches deep, and the reason that they're shallow is photosynthesis takes place in the top foot of water. And what is so awesome about this particular fuel is it consumes carbon dioxide to grow. So the first place they want to put them is around coal burning operations, because it will clean the air to consume the carbon dioxide to grow the algae, and then it burns clean. So this is a type of technology that we're very excited about participating in, being the pond liners for the biofuel. And the problem with the existing pond liners is they're a synthetic plastic that is breaking down in the intense UV light in the top 1 foot of water. And if a cow or deer or elk or antelope steps on that plastic, it tears it. And if we create a 6 or 8 inch earth liner that cannot be, you know, nothing's going to tear it and it's not going to be affected by the light, the UV light, then that provides a solution. And they are very close. They started out with this technology. It cost them $150 a gallon. They now have it down to $8 a gallon, and the goal is once they get to $5 a gallon, they go to full commercialization. And currently, 50 cents on the dollar, $4 out of the $8 a gallon, is the pond liner. So we're working with them to bring that cost down to get it under $5 a gallon, so that biofuel can be a real alternative to get off of fossil fuels. And another technology is for agricultural pond liners is one, and also for landfills, lining and capping landfills. And just one project we did in Louisiana was a road leading into a landfill, and they have learned how to cap the landfills now and contain and sell the methane gas that comes out of the landfill. In fact, the one in Louisiana, they sold $100 million worth of methane gas to British Petroleum, and they had 5 customers lining up to buy the methane gas because they all get carbon credit for their tax reduction in using renewable fuels. And the problem with the current liners is it's designed to contain liquids, not gases, and 30% of the gas is escaping into the atmosphere. So again, we can create an earth liner that contains all that gas and can be used as a renewable fuel, and we can protect the base from having all of the nasty stuff in the bottom of a landfill getting into our water tables and sealing it up and not having seams coming apart and tears in the landfill liners. So these are all different kinds of technologies that we are excited about participating in that can make a big difference in helping the planet.
Well, it really is an exciting technology. It's an exciting future. The possibilities are really endless as you are continuing to see the many ways it can be applied. And we need to tell people where to go to learn more, especially if anyone listening knows anyone who's a supervisor of roads or contracting roads or pond liners. They need to know about this, and they need to know where to go to get to this information, Bob. So what's the best website to send them to?
The website is LithTec.com, and that's spelled LITHTEC.com, LithTec.com. Our 800 number is 877-437-9468. And you could email me directly at bob@LithTec, LITHTEC.com. And please tell us that you learned about it on Dr. Cheryl Selman's podcast, and then we know how you found out about us, and we really appreciate it.
And maybe they'll get a LithTec brick or something, win the prize. I'm excited about this. You've done such a great job inspiring all of us listening, because it's a topic that we don't really have much access to, and at least not in my world, and I'm sure most people listening really never knew as much as they now know about building roads and about the new green technology that's available that you've dedicated your life to. And I just want to thank you for the hard work that was needed to bring this to market, and for all your time today. It was a fascinating show. Thanks so much, Bob, for everything you're doing.
Thank you for having me on the show. I really appreciate it, and thank you to all your listeners as well.
And, yes, to all my listeners, thank you all for tuning in again to another episode on What Women Must Know. You never know what you're going to get on the show, so you don't want to miss one episode. And until next time, as I always like to say, honor the wisdom of your feminine self. Bye for now.